we have now the centroid. So centroid is simply the center of any polygon that we need to get. So it is also called the center of gravity. So it is a point. So we will denote this as G with X bar and Y bar for a mass which is also called the center of gravity. So using the Varignon's theorem, we can have that the moment of resultant is just the sum of moment of components. So we have here the formula, okay, which is the X bar or the centroid with respect to the X component, that will be M X bar all over M. So in this case, you cannot cancel M because M X bar, which is the numerator, will contain a differential or dy or dx. Okay, so that will be the same with y bar or the centroid with respect to the y coordinate. And then cross multiplying it, so you'll have mx bar equal to the integral of xc, which is a centroid, x centroid, dm. So dm can either be dy or dx or whatever variable that you will be using, where m is the mass. So remember that m or the mass is also replaceable by area or volume. Okay, so note that x bar and y prime and y bar will be equal to 0. So if m is symmetric with respect to y-axis, and y bar will be 0 if it's symmetric with respect to the x-axis. Okay. So if we have another one, which is a centroid of composite figures. So a figure which is composed of figures with known centroids. So we already have the formula here, which is the x bar equal to the summation of mx bar all over summation of m. So again, m here are still replaceable by area or volume. So without further ado, let's get into the first example. So we got here for number 1. Okay, so find the abscissa of a centroid of a quarter circle. So I already drew the quarter circle. So of course, this will be your x-axis and this is your y-axis. So abscissa, therefore we are asked to find the x bar. Okay, the x bar. So we can use the formula, which is m x bar equal to the integral of xc dm. Okay, dm. But in this case, we can replace m with the area because we don't we have the data we have is the area. Okay, so area x bar equal to the integral of xc dA. Okay, so if we have dA, so getting the dA, just use the area method. Okay, so we can have here a rectangular strip. Okay, rectangular strip. So using a rectangular strip, of course. Okay. So of course, this will be your x and this is your dy, since that is a rectangle. And then if I will say that this is the centroid, therefore I can simply say that from here to here, that will just be the x over 2. Right? X over 2. And that will be your xc. So with that data, you'll have your dA. To get the dA, that is just a rectangular strip. So rectangle, that is just x dy. Okay, and then your xc is just simply x over 2. Okay. And then of course, since the radius is a, so from here, that will be a, and then from here, this is your. So remember that a quarter circle is just 1/4 of a whole circle. Okay, so with that, let's substitute all the values. So a x bar equal to the integral of xc, which is x over 2, and then your dA is just x dy. Okay, so we still have a limit. So limit, of course, that is from 0 to a. So ax bar equal to integral of, I can bring out 1/2, right? So I can bring out 1/2. So this will be x squared dy. So again, since this is dy, we have to make x squared in terms of y. And then going back to the figure, remember that if that is a circle, therefore the equation of that circle is, using your analytic geometry knowledge, that is x squared plus y squared equal to a squared, since a is your radius. Therefore, we can say here that y squared is equal, not y squared. X squared here is just simply equal to a squared minus y squared. Okay, and then now we can substitute that equation to here. So replacing the x squared, you'll have 1/2 integral of a squared. This is from 0 to a. Okay, from 0 to a minus x. No, not x squared, y squared. Y squared dy. Now we can apply the integral. So 1/2 integral of that, you'll have here a squared y minus, okay, y cube over 3. Okay, that is from limits from 0 to a. Don't forget that we still have a 1/2 outside. Therefore, you'll have here 1/2, and then this will become, substitute a. So 0 will just be 0. So I will no longer write that anymore. So you'll have here a cube, right? Because replacing y with a, and then this will be a cube over 3. Okay, and then you still have here minus 0. Okay, but that is just minus 0. So simplifying that, again, this is ax bar, right? Ax bar, and then 1/2. Simplifying that, you'll have here 2/3, right? That's a cube minus a cube over 3. That's 2/3 a cube. So as you can see, we can cancel out this. So we'll be left with 1/3 a cube. Now we can apply the area. So looking for the x component or x bar, you'll have your 1/3 a cube all over a. Okay? But we already know the area of a quarter circle. So the area of a whole circle is pi a squared, right? And then since that is a quarter circle, you have to make 1/4 here. Okay? So simplify. So a cube over a squared, that will only give us a. So simplifying that, you'll just have 4a over 3 pi. So this will be the centroid of the quarter circle. Remember that your a is the radius. Okay, your a is the radius. Okay, so I think that's done. Let's get into the next problem. For number 2, locate the centroid of the hemisphere from its diametral plane if its radius is 8 centimeter. Okay. So since we are looking for the centroid, as you can see, this figure, this is already a hemisphere. That hemisphere is just 1/2 of a sphere. Okay. So just remember that. So hemisphere is 1/2 of a sphere. Okay. And then, since hemisphere is a 3D, right? So we'll be using volume now. Okay. So we'll be using volume. So as you can see, this hemisphere is already symmetrical with respect to the y-axis. So we already know obviously the location of the centroid with respect to x, which is just, it will be just along this one. It will be just here, right? So it will be just along this line or the y-axis. So all we have to do is just find the centroid, the y-coordinate, the centroid of the y-coordinate. Okay, so we'll be using volume now. Volume. So we'll be using v y prime, not prime, bar, integral of yc dv. There you go. Okay, so this will be the formula we'll be using since I replace the m with v. So as you can see, since this is dv, therefore we have to use this method or any volume of revolution. So since we have to use a volume of revolution, we have to get this one, horizontal strip. Okay, so why horizontal strip? Because I'll be revolving that with respect to here. Okay, so that is the revolution. I cannot revolve it around here, because therefore that will not make a hemisphere. Okay, so I'll be using only the half of the hemisphere. So if I will revolve this area, I will now be able to get the whole hemisphere. Okay. So of course, this will be your x and this is your dy. And obviously, your yc will just be your y. Okay. So yc is just equal to y, but getting the dv by we can use now the by this method. Okay, this method. So using this method, of course, that will be v equal to the um, integral. Okay, integral of you have here pi, so that is x squared dy. Okay, that is x squared dy, right? So x squared dy. But if I will get the derivative of both sides, therefore I'll have here dv, and then getting the derivative of an integral, so you'll just cancel out the integral. So pi x squared dy. Okay, so this will be your equation. So let's try now to substitute those. So v y bar equal to the integral of yc is y, and then dv is just pi x squared dy. Okay. So what will be the limit? So of course the limit, that is just from, since we are using only half, so 0 to r. Okay, so 0 to r. So this is r, right? Since the radius is r. Or yeah, we can just use r. We can just substitute 8 later on. 0 to r. Okay. And then equal to, this is integral of 0 to r. So we can bring out pi. So you'll have here y x squared dy. Okay, going back to the original. So remember that this one, okay, the equation of this one, since that is a circle, okay, the circle, you'll have your x squared plus y squared equal to r squared. So we are looking for x squared, right? Therefore, x squared is just simply r squared minus y squared. Okay. So let's do that. So pi integral of y times r squared minus y squared dy from 0 to r. Okay. So pi 0 to r, that will become r squared y minus y cube dy. Okay. Okay, so I'll just continue it here. So you'll have again v y prime equal to, so applying down the integral, so applying down the integral, you have here pi r squared y squared over 2, right, minus y raised to 4 over 4. That is from 0 to r. Okay, so that is pi times that will become y raised to 4 over 2 minus no, not y, it should be r, sorry. So this should be r. So r and then r raised to 4 over 4. Okay. No. Okay, so now we can simplify that. So simplifying that, you'll just have pi over 4, right? R raised to 4. Okay. And then don't forget that we still have your vy prime, and then you'll have your y prime equal to pi over 4 r raised to 4 all over your v. So we have here pi over 4 r raised to 4 all over your v. Now is since that is a hemisphere, so the volume of a sphere is pi r cube. But this, since that is a hemisphere, half of the sphere, so you have here 1/2. Okay. Okay. The volume of sphere is 4/3, right? No. The volume of sphere is 4/3, but half of that, so this will just become 2/3. Okay. Is that right? Yeah, I think that's right. So this will become 3/8, right? The pi will be cancelled. So 3/8, and then r will be cancelled. You just fill it with 8. Okay. But we already know that r is equal to 8, right? We have a given of this is 8 centimeters. Therefore, 3 times 8 times 8, 3 over 8 times 8. This will just become 3 centimeters. So this will be your answer. Okay. So let's get to the next problem. So getting to number 3, so locate the centroid from the base of composite area made of square with side 8 centimeter and surmounted by a semicircle. So this is already the figure. I already drew it. So let's just put the um, measurements. Okay, so we have here. So since this is a square, no, so 8 centimeters. So that's if that is a square, therefore all of the sides will be square. Okay. Therefore, so you can see if I will put a line here, okay, line here. There we go. So again, the figure is symmetric with along with respect to the y-axis. Therefore, we'll be only looking for the centroid along y-axis, okay? Because it's already obvious that the y or the x will be just in this line, or the centroid along the x centroid with respect to the x will just be along this line. So you don't need to find the x. So we're looking for the base. If we will say that this is our origin, therefore this will be our 0. Okay, so this will be your 0, 0, right? Okay, that will be your 0, 0. So the area will be using the this one, centroid of composite figures. So a figure which composed of figures with known centroids. Okay, so it is almost the same, and again m r just are still replaceable. Okay, so what will happen here is, so we already know here that the x bar is equal to 0, right? So the center is at 0 for the x bar, but for the y bar, okay, so for the y bar, since that is just a 2D, we can have here the summation of a y prime over summation of area. Okay, summation of area. And in this case, we'll have here the area. We have two figures, right? A semicircle and a square. So first the square. So area of the square times the centroid. Let's just call it YC. Okay, YC of the circle of the square. Okay, okay, that is y and centroid of the square plus now the area of the semicircle. So let's just call it SC. Okay, SC, and then y of the SC. Okay. All over area of the circle plus the area of the semicircle. So what happens here is this y prime now is equal to the area of the square. Of course, the area of a square is just the one side is 8 centimeters, right? So this is just 8 squared times, so the area, so the distance, okay? Distance of the center of the square, just the square. Okay, distance of the square to the centroid of the square. So distance from here, okay, from here to the center of the square. So center square is here, right? So this is just 4, right? 4 centimeter. Okay, so this is just 4. Plus now area of the semicircle. So area of semicircle, of course, that is, since that is semicircle, so we have here 1/2 pi and then the radius. So if this whole line or the diameter is 8, therefore the radius is just 4. So we have here 4 squared. And then you still have to times this by the centroid. The centroid of a circle, semicircle, we already computed for that. The centroid of a semicircle is, for the semicircle is 4r over 3 pi, right? Okay. So this distance is from here to the center, okay? So center of semicircle is here, right? So this is just 4r over 3 pi. But we are looking for the centroid from the base. So from here. So you still have to add 8. 8 plus this one. Okay. So therefore, this must be 8 plus 4. R is also 4. 4 over 3 pi. All over a squared, the area of a circle, plus 1/2 pi 4 squared. Okay. So if you will use your calculator, you will get here 5.6. Okay. Therefore, the centroid of that figure will just be 0, 5.6. So this will be your answer. Let's get into the next topic.